Hey guys, today we're gonna be looking at interfaces, how they work, and a common gotchas that trip some people up when they're just starting to use them. So if you follow me to the screen, so the first thing I'm gonna do is I'm gonna declare a speaker interface that has a speak method. This is the syntax. You say type speaker, and instead of saying struct like we did before, for instance, we say interface, and then in between brackets all the methods with their signature. So the second thing I'm gonna do is I'm gonna create a person struct like we had before with a speak method that returns a string, and then I'm also gonna declare a duck that also has a speak method. So because these two types have a speak method on them, they are speakers, or they implement the speaker interface. So unlike Java or TypeScript, where you have to go and say that the class implements speaker, in Go, types implement interfaces implicitly. So if it has all the methods that the interface demands, that's enough for them to implement the interface. You don't have to do it explicitly, which is really cool because it means that you could create interfaces for types that were made by somebody else, and maybe you can't go to them and say, hey, change your type to implement my interface, which is a problem that sometimes happens in Java or TypeScript. So let's see an example of that. I'm gonna create a greeter function which is going to receive a speaker. So this could be a person or a duck. It's just going to return a string and call the speak method on that variable. First, I'm going to create a pointer to a person that I initialize explicitly. Then I'm going to create a pointer to a duck that I initialize explicitly. And then I'm going to call the greeter function with the person and with the duck. Because they're both speakers, I can pass in whichever one of those to this function. So let's run this. And you'll see that it works for a person and it works for a duck. All right, so that's pretty simple. Now I'm gonna show you something that usually happens that catches people off guard when they're using interfaces. Let's say I come here and I delete these two lines. And so I'm gonna define a variable of type speaker. If I check speaker, I haven't assigned anything to it. This doesn't know if it's a person, a duck, or whatever. So it's gonna be nil. Let's just comment this out so I can run this. Effectively, speaker is nil. Okay, fine. Now, let's say I have, instead of this, I have a variable of p, which is a pointer to a person, but I don't initialize it. So this is a nil pointer now. So what happens if I assign to speaker p? Speaker is a person, but it's a nil person. This should still hold, right? Still nil. Let's try to run this. Okay, the speaker is not nil anymore, but it is pointing to a person. Okay, so you might say, okay, it's not nil, so I should be able to say speak, right? Because we check for nil. Let's put this in an else so it's more clear. If it's not nil, then I should be able to say speak because it's not nil. So let's test this out. It panics, okay? Nil pointer, dereference. So this fails. Why does it fail? Well, because I'm trying to call speak on a person, but that person is, the value is nil. So to understand why s is not nil, you have to understand that this variable here has two things inside. It has a value and it has a type. If both of these things are undefined, I don't know what they are, like here, I don't know what value this is, I don't know what type this is, then the interface is effectively nil. Okay, but when you do this, you're saying, hey, you're a speaker, but not just any speaker. You're a person speaker. So the type here is replaced to person. But the value remains nil because P is a nil pointer. Okay, it's pointing to nil. So this is going to be nil. When you ask if speaker is nil, this will return true only if both of these values are still not defined. If you don't have a value and you don't have a type. But here, after doing this, okay, we don't have a value, but we have a type. We're a type person now. Okay, so this will not return will not return true anymore. And that is a little tricky if you're just starting out with interfaces. Now, something you could do is, if this is a person, you could catch for that here, as I've shown you in the previous episode. And if we run this again, you'll see that, oh, I have to print this. You'll see that now it doesn't panic. And just for the sake of completion, let's actually assign something here. And let's run it again. Okay, so you see that it works. So this is something to watch out for. You might have thought, hey, I'm assigning something to s, but p is a nil pointer. So s will still be nil, false. Once you set a type on an interface, even if the value is nil, the interface will not be nil anymore. All right, so the last thing I have to tell you is the existence of the empty interface. So if I do something like this here, and I'm not gonna spend time fixing the errors, but this means that S could be anything. The TypeScript equivalent to doing this would be like S is of type any. You can see that you can't call any methods on an empty interface. You have to cast it first. Now, for you to understand what an empty interface means and why it's equivalent to the any type, let's look at the speaker interface. So if you wanna be a speaker, you have to have a speak method. Now, if you don't have anything here, and this is an empty interface, what do you have to do to be a speaker? Well, nothing. You don't have to do anything. So everybody can be a speaker. Well, when you have an empty interface, that's what you're saying. S could be anything. And you can check on the types. You can say if S ends up being a dog or if S ends up being a person or whatever. Or you can just use the empty interface if you don't need to access anything and you just passing things around. But this is a useful type to say, hey, I don't know what S is going to be. It depends. And you might want to check some other value to know what S is or whatever. Now, you should limit the use of empty interfaces as much as possible. Like if you can avoid them, right? It's something you use when you absolutely have to. And I'll give you concrete examples of when you have to in future videos. But I just wanted you to know that this exists and that you can use it. All right, guys, I'll see you in the next video. I think we're going to talk about maps.